I thought I might do a quick video, Big Clive Diodes Gone Wild style, concerning this USB 6 outlet charger. You can probably tell by the grubbiness on top that I've already had it apart actually, and I'm actually filming this introduction at the end. I bought it basically because it's got the 6 outlets, and because it has a relatively high, at least in theory, has a relatively high capacity, although that's one of the reasons I wanted to take it apart. It has a display on the front that nominally shows volts and amps, which is one of the reasons I bought the unit, because I find it's often quite useful to be able to see whether something is actually charging, or whether it's, or if it's not charging, why it's not charging. You can find these all over the internet, from on AliExpress and eBay and so on, very similar models. They tend to have WLX-T9 Plus in the description, which is actually the name of the chip that drives the display. So it can nominally output total of 8 amps at 5 volts. Whether it really can, I must say I have my doubts. And you'll see that it's got one quick charge outlet which can put out 9 or 12 volts at various amperages. And I found a few problems with the unit just from the outside. I thought I'd take it apart and see what I can see. So as you can see, I've already taken the top off. If you do want to get this off for yourself, I found squeezing it in a vise broke the, it's glued on, the top's glued on, it doesn't unclip, it actually glues on. Yeah, if you squeeze it a bit, you can crack the glue and then it comes off reasonably easily. Inside, one of the first things I noticed is huge lumps of silicon down in here holding the main board in, which I'll dig out and then see what else I can show you. So I've loosened up the glue, and I think this should be loose now. Okay, it comes out, and hopefully I can pull the board up out of its slot. Yeah, it comes out. Okay, there it is. So I wasn't going to really look at the power supply side of it because I was more interested in the output, but I had a quick look. Clearly it's been repurposed. You can see where they've snipped off the old output leads here, snipped off the old input leads here. And it's been very crudely thrown together. The soldering is terrible where they've tacked on the leads for the new leads for the mains here. It's very grubby around here where they've soldered on the new leads for the output. But having said that, it's probably come from a reasonably high quality piece of equipment. You'll see it's got an absolutely enormous spacing between the high and the high and the low voltage sides here, with a proper gap here. I think it's a proper class Y capacitor between the high and low voltage sides. So if the transformer is as high quality and with such good gaps as the rest of it, it's probably reasonably safe. Who knows really, but there's no particular reason to think it's unsafe, put it that way. So that's the actual power supply. So here's the back of the board. I've beefed it up a little bit just because I was concerned that it was dropping voltage across this main positive track by giving it a heap of solder along here, and I did the same with the negative connections as well. That really hasn't made any difference to anything. Now each USB plug, one here, one here, one here, one here, one here, one here, has a resistor here. It's a 0.1 ohm resistor, and it's for current sensing. And the resistors are 0.1 of an ohm each. Now, to me, that seems quite high for current sensing. I'd be really interested in the comments of anyone who knows about these things as to what a more normal value is, or whether that is a normal value. The thing is that at high resistances, at high amperages, so if you're charging an iPad at full amps, which is so 2.4 amps or so, each of these resistors is dropping about 0.6 of a watt. I doubt these are even able to cope with that, or expect to cope with that. They're extremely hot, so hot you can't touch them. And they are dropping nearly 1/4 of a volt just on these resistors. It just seems ridiculously high to me. I'm just trying as an overall capacity test of the board, setting it up with 3 loads all at full 2.4 amps, which should take it up to capacity almost. So you can't see it very well, but this is the USB board of the power of the USB charger. I've got one USB load here, another USB load here, and then I've got another load that's hooked in through this cord, which is coming over to these 2 5-watt wire wound resistors here, which should draw about another 2 amps. And this one I'm going to use to measure voltage under that sort of a load. One of the things that I've realized from my earlier testing is that the USB connections are really pretty crap, and they tend to drop a few tenths of a volt just across the connection. So it's not entirely fair to measure using the outputs on these the inputs on these USB measurement devices, because they are actually a bit lower than what the USB supply is providing, because they're losing a few tenths of a volt in the connections. We can't really blame the board for that. So if I turn this on now, what we should have here is we've got 2.1 amps here. You can't see it, but there is 2.4 amps on this one and 2.3 volt on that. So that's around about near enough to 7 amps being drawn there. And if I, now it looks here, it says 4.57 volts. And on this one, which you can't read, it says 4.68 volts, which is a bit low. But what is the actual supply? If we go on to here, just trying to hold this without bumping it all, what we find is we've got about 4.86 volts there, which is within range, not by a great margin, but it is. And $4.89 there, and $4.87 there. So it is actually supplying the over 4.75 volts, which is the USB standard, to 3 outlets, while providing all of them with a total of over 7 amps. So it's pretty powerful. But the interesting thing is that if I measure just straight across the rails here, it is providing 5.1 volts, no problem. But it is losing about 1/4 of a volt across the current sensing resistors in lines, which means that not only are they getting very hot, because they're coping with about 0.6 of a watt each, but they are not insubstantially dropping the voltage down to the level where it's almost too low. I'd be really interested in your comments as to whether a 0.1 ohm resistor for measuring for current sensing in this sort of device is usual. To me that seems quite high, and it just seems like a waste of power, but and just, it nearly puts this thing below spec, just using such a high value for their current sensing resistors. Interestingly, I pulled apart another USB power supply that I've got, just kind of similar actually, this one here, today, just to see what it had, and it also has 0.1 ohm current sensing resistors in it. So it does seem perhaps to be the way they are done, but it does seems remarkably high to me. If you've got any comments on that, I'd be really interested to read them. So I've set this up now just to show you how this display works or doesn't work, depending on how you look at it. I've got this running 2 loads on cords so that I can twist everything around so you can see it. This load here is running 2.4 amps, It's showing 4.57 volts, but it will actually be higher than that due to resistances in the cable. And this one is 4.58 volts, not quite 2 amps there. Now, if you look on here, and it's a bit hard because it's a bit flickery on screen, but I'll see what I can do about showing you. You'll see it says 5.2 volts up the top line. That is a lie. It's a flat out lie. That is a permanent display. I tried running this off my bench power supply, just putting 4 volts into it. This still shows 5.2 volts. So the top line is meaningless. It just always says 5.2 volts. The bottom line, the first digit, is not to do with amps. What it is the outlet number that is it is currently displaying. So it's currently showing 2, which is this one, and 5, which is this one, alternately. And it's showing 2 as 2 amps. Well, it's more like 1.9 actually. And it's showing 5 as 2.6 amps. It's actually more for like 4.2, which is pretty much, I've tested all the outlets under a variety of loads, and it consistently reads about 0.1 to 0.2 of an amp too high all of the time across all ranges. So it's not really calibrated very well. In terms of how well it works, I don't particularly like the rolling style. I mean, it's okay, but you know, if you can't just glance at it and see what amperage it's putting out, because you have to wait till it comes around to show you the right one. But anyway, I suppose it works. I was just going to put this back together as is and call it good enough, but well, on the usual principle, I can never leave well enough alone. I was thinking about it and thought that the voltage is a tad low, particularly at high amperages, and I wondered if I could just tickle the voltage on the power supply up a little bit, and thereby improve the voltage level of the USB outlets. The power supply was clearly set up to produce exactly 5.2 volts. It's losing little bits of voltage along the way, such that, as previously mentioned, when it's putting out 2.4 amps, the drop across the current sensing resistors is sufficient to put the voltage very close to being below, or in fact below, the minimum USB voltage. Now, so I had a bit of a look at it, and it's pretty clear that this is the voltage reference on the power supply board, and here are 2 resistors that are a voltage divider that sets the feedback being given by the reference through the opto isolator here, optocoupler, whatever you want to call it, here. The original resistors, I've already changed them actually, were 1100 and 1200 ohm, and that produces 5.22 volts, I think. What I've done is I've changed them to 1600 and 1800, and that should bolster boost this up a little bit, so that it instead puts out around 5.31 volts. So if I now plug that in and put a load on it, you'll see that at very low amperages, where it's not losing much across the current sensing resistors, it's right on 5.24 volts, which is just within the top range of the USB spec. And if I now turn this up so that it's producing the maximum, which is about 2.4, you'll see it's now on 4.785, which is a nice proper lower end of the range, but still a proper USB voltage. With the way they've done the current sensing resistor, it's not possible to have this set up so that it produces a steady 5 volts across a wide current range, because it's always going to be that at the top end of the current range, the current sensing resistors are going to be stealing voltage and reduce the voltage down, and then at the bottom end of the range of current, I mean, when it's very low current, it's going to be pushing the upper end of the USB acceptable range. So I'm happy I've adjusted that now to about as good as it can be, but it does mean that there's about a 0.5 volt difference between the top and the bottom of the range, depending on what current's going through it. So that's about all I think I'm going to do with this unit for the moment. Let's put the lid back on and away it can go.